Welcome to this next talk in the Edge session. It's a pleasure to me to welcome Scott Colton. He is a principal software engineer at Puppet and also, which makes me really proud, a Docker captain. My name, by the way, is Gabriel Schenker. I'm the principal content developer at Docker. Please take it away and talk about containerD.
Good afternoon. Thank you very much for coming to my talk. I know there is actually another awesome talk on at the moment with Laura and Stephen, so thank you for coming to mine. When I originally thought about this talk, it was called Looking Under the Hood containerD. But what I really should have called it was containerD, what does it mean for me? So the talk's actually going to be about how can you consume containerD in a software sense? How can you build tooling around it? How can you develop software on it? And how could you deploy and deliver software on the bare minimum product that is containerD? A little bit about me. I'm in the Docker captains. I work at Puppet. You can get me on GitHub there and Twitter at Scott Colton. And as you can tell from the accent, I'm actually from Sydney, Australia, so it's a long way from home. So the agenda today. First of all, before we can deliver software on top of containerD, we need to know what containerD actually is, what it gives us. Then find out why containerD is actually a critical part of the container ecosystem. What upstream projects use containerD? And how is containerD changing the way we build container products? So we'll go through all this and we'll do various demos throughout the talk. So what is containerD? So I've just plagiarized this straight from the containerD website. But basically what this boils down to is containerD is the industry core for container runtimes. So all other container higher level tools like Docker itself, Kubernetes, is built on top of containerD. But what does containerD actually give you? So once you have containerD running, what is it? There is a CLI for containerD called CTR. How many people know what gRPC is? Oh, awesome. This is last time I did this talk, one person put their hand up, so I spent the next 5 minutes talking about gRPC. So there's a daemon that's exposed the gRPC API over a local Unix socket. That's really important because there's no traffic traversing the network stack. So it's localized only. And there's protobuf specs between any of the other components. So if you want to hook into containerD through code, you've got a set of specs that is a contract that you can start running your code on top of. So this is basically what containerD does and what it looks like. This is the architecture of it. So as you can see there's a gRPC interface. You've got different metadata around what the containers look like. You've got tasks and events. You've got the runtimes, which could be runC or whatever else underneath it. And then you've got the lower level primitives in the OS, which would be kernel level things that you would boot up depending on what your application needed sitting on top of containerD. So this is a very high level architecture view of what containerD actually is. This is CTR. Don't get this confused with the Docker CLI. This is a tool that is currently unstable. But it is really, really handy if you're debugging building tools on top of containerD. It allows you to have a look at what is actually working in containerD. It allows you to have a look at the processes running, what containers you've got. It allows you to pull. It allows you to modify namespaces, see a whole heap of things that you can do with code in containerD. So it's a really handy troubleshooting troubleshooting tool. Now, I was going to write code to do everything today, but I'm actually going to use CTR. Because it'll make it a lot easier to explain what I was doing than putting Go examples up there. So what does containerD give us? Like, why would we want to build tools on top of containerD? So why we were looking at it, we were actually looking at Puppet at a few different proof of concepts, and we wanted to build a cloud-native application, perhaps. Could have been Puppet open source, could have been anything. We were just doing R&D. And what was the minimum viable product we could build on a container runtime, but not be tied to any other, like the Docker release cycle? So we needed something that was lower level, that we could that was like LTS, like containerD. So like, there's not as many changes going into containerD as there is obviously the Docker runtime. So we wanted to see what the minimum viable product we could ship to a cloud image was. So containerD was what we started to do R&D with. And what we wanted was OCI image spec support. So we wanted to make sure that we could use any image that was already upstream or that we wanted to build. We wanted to use runC. I know there's other choices out there, but it just made sense to work with runC if we were already using containerD. We needed image push and pull support because we thought at the time if we were going to deploy this, if it needed to be on something like an OS that someone had already had, we could install an RPM that would actually install containerD or an app package, and then it would then pull the images from upstream in a registry somewhere. These are all sort of things that we were toying around with. And obviously we wanted management of namespaces because we were thinking, can we use a namespace, and if it didn't need network as such, could we get away with running rootless containers? This is all, as I said, theoretical proof of concept. This is not something we're going to release. But these were the sort of things we were toying with at the time to see what the minimum viable product was that we can get away with and play with just to find out what we could do in the future if we needed to deploy any like real-life applications to the cloud. So I'm just going to show you a quick demo now. There's actually going to be a few demos. Because it's actually really late at home, I've actually cheated and put all my commands on this side because jet lag has been bad. So basically what we're going to do here is we're just going to pull an image. So we're basically just going to use CTR pull, and you'll notice that the image name is actually the full qualitative name. That's because when you do Docker, it actually appends that to it when you do Docker pull. But containerD is not opinionated about where you're going to go for the registry. So this could be using, it could be in Kubernetes, and it could be using something like the GCR registry, or it could be Quay, or it could be any other registry. So you have to put the fully qualitative name of the image. But if you just go pull, you can see there that, there you go. We've just pulled the Redis image. So that was pretty basic stuff. But as you can see, you've got all the low-level primitives that you need to be able to pull something from upstream. So your CD process wouldn't change if you were deploying it on a Docker image, a Docker runtime or containerD runtime, as long as you're using an OCI spec image. And we can just run that now, so I'll just, that's not going to work. I'll just come here and paste this. And I'll actually make this bigger so you can see. And now we're just going to run that image. There you go. So we just run Redis with no Docker engine, just on top of containerD. So now you can see that we've got the low-level primitives that we need to run an application. That's a fully working version of Redis, and as you can see there, it's ready to accept connections. So that gives you the building blocks now to start to deploy containerized applications that may need to be immutable. It might be in a package, a complete package that's immutable. There's a lot of use cases of why you would build applications on top of containerD and ship images, like OCI spec images, for stuff that's totally immutable. That's better. Just go back to the slides. So basically what I wanted to show there was just that you have the low-level primitives to be able to pull an image and run a container from that image. So now we know that you can do the basic levels of what you have in Docker. So you don't have any of the fancy stuff. Obviously, they're like a remote API over REST. Any of the other stuff that comes like Swarm mode or anything like that. I actually almost had a demo working last night where I was going to run SwarmKit on top of containerd, and you can actually cluster it. It's kind of stable, kind of not stable. I didn't have enough time to get it ready for the demo. Maybe in the next time I do a talk, I'll have that ready. But yeah, you can do some really interesting things. But what other upstream projects use containerd? And how does the architecture allow it to be pluggable? So you've got here that you've got the API client, which is a gRPC client. So cry containerD for Kubernetes, Moby. I saw a really interesting talk where Microsoft today had HCS, I believe it was, that sat in front of containerd. That was some really interesting stuff that they were doing. So they can plug in all their applications that they're building to run Linux containers on top of Windows because containerd is so pluggable. And that's what I'm trying to show here, the API client and building tools around containerD so accessible that any of the container runtimes makes your trace pluggable when you're trying to build applications that work on top of containerd. So as you can see there's, as I said, it could be the Microsoft plugin, it could be the cry containerD, which is Kubernetes, or it could be Moby, which would be the Docker engine itself. There's containerD, and then you've got runC down the bottom, and then you've got all your storage, file system, and OS primitives below containerD. So this allows other projects, as I spoke about, to sit on top of containerD. So as you see there, you've got Docker itself, SwarmKit. As I mentioned before, I was trying to get a demo of SwarmKit working without the Docker engine and clustering it up on top of containerD. It is completely possible. It's just like a proof of concept type of thing. You've got Kubernetes, as we saw the announcement yesterday. Docker is going to be supporting Kubernetes, and that will most likely be running on top of containerD. You've got all the other, like Microsoft ACS, OpenShift, Google Container Engine. So this is how containerD, people are building software today on top of containerD. So if you have a look at everything there's a lot of software being built on top of containerD. So you might think it's weird that we were R&Ding on what we could do with containerD. It's because there's so many other frameworks built on top of it. It was a really good. We wanted to see what we could do. The other good thing about it is, as you can see, it's mostly at the moment, it is still in beta, but it's mostly supports multiple OSs, which makes it powerful when you're trying to ship applications to other people, because they obviously might have preference of OS, whether it be Linux or Windows. And as I said, there was a really good talk earlier in this track about Linux containers on top of Windows. So containerD is mostly used in, we're going to talk about today Moby and what Moby actually is. Moby, LinuxKit, and we're actually going to talk about that separately because we're going to delve into LinuxKit. And last of all, we're going to talk about Kubernetes. So how many people actually know what the Moby project is, and when it dropped last year, last DockerCon, what it meant for the Docker engine? So not too many, just a few. The Moby project is all the pluggable parts it takes to make the Docker engine. So containerd would be definitely a main part of that. The Docker engine itself, you got SwarmKit, HyperKit, which is the virtualization platform for Mac OS that runs Docker for Mac. You got LinuxKit, which we'll talk about later. You got runC. All of these parts make up the Docker engine that you've got now. I mean, going forward, it might even be the Kubernetes service that will be inside the Docker engine for Docker EE will be part of the Moby project because it will be shipped as part of the Docker engine. So Moby is a whole heap of tools that make mostly the Docker engine, but you can take bits and pieces of the Moby project and you can start to build tooling on top of it because it's fully plug and play. So like as I spoke about SwarmKit on top of containerd, HyperKit runs Docker for Mac, all this stuff's plug and play. So that's what the Moby project is. And now, after this DockerCon, seeing the announcement of Kubernetes and Swarm together, you can see why the Moby project and the Docker engine got broken up into pluggable bits, because it now gives people the choice to use whatever runtime you want, whatever orchestration method you want. And all this is really broken up nicely, not only from to build software, but from a contributing point of view, it makes it really simple because all the services are cleanly broken up into their own little pieces of the world, and then they come together to build Docker, mostly, or it could be Kubernetes now. So how does containerd interact with Moby? So this is containerd 1.0. I'm using 1.0 beta 2. But basically you can see that it's the lowest level before any of the OS, above the OS. And you can see there's the API, and then you've got things like the Docker CLI, SwarmKit, system storage, system distribution, any of the networking. So that networking could be lib network that Docker uses, or it could be the CNI plugin for Kubernetes. DataKit, InfraKit, any of these sort of things. But you can see down there, containerd talking to the host storage and host distribution, and the network interface management if the namespace in the networking is already created. And then you've also got the supervisor, the executor, and then the runtime for the container itself. So I hope that shows Moby projects as a whole. You can now start to swap out things in there after yesterday's announcement. So SwarmKit might be removed for the Kubernetes service or the Kubernetes framework, but it still gives you the end-to-end container, runtime, and orchestration layer. So how is containerD different from Docker? So you've seen me do a run and a pull. So what is completely different? So Docker's got a whole heap of stuff on top of it that's a value add that containerD doesn't. So things like compose, things like build. These are all sit on top of containerd. Containerd is not worried about this at all. Containerd already needs to ingest an image that's already built. It won't do build for you. Any of the RBAC controls around like trust or anything like that is built into the Docker engine itself. Any of the Docker REST APIs, any of the clustering that goes into running it on multi-nodes is all sits above containerd. So as you can see, there's a lot of difference between Docker itself and containerd, even though like I'm using the CLI for containerd in this particular talk. So we're just going to do a demo again. So I'll just get out of this. So basically what I'm going to show now is I've got a container I've got Docker running right now. But if I go Docker, it's not found, which I'm like, okay. But it's actually running in the container. So so if I just go and use this command, I'm just going to see if I can hit it. And there you go, Docker PS. So Docker is running. Where's it running? So Docker is a service inside running on top of containerd right now. So containerd is actually supervising a container that's running a full version of Docker. So what I'm actually shipping is a cloud image that has Docker running. This is very similar to the way Docker for Mac and some of the other tools are set up. But this is a fully functional version of Docker. So we'll just explore this a little bit more, and we can go Docker version. And as you can see, it's the latest version of Docker in CE. But we might want to go further and actually run an application just to prove it's working. And we're just going to run Alpine again. So now you'll see that the pull is actually different. It's actually using Docker, because Docker is actually segregated in a different namespace now from containerd. So containerd has created a namespace on the underlying OS, and as you can see there, Redis is running. So that's ready to go. It's actually running in the foreground. So if we go Control C, so we can go that. And we can go Docker PS. As you can see, it's there. So this starts to show you that this is like a bit of an inception, but what I'm trying to show is that containerd can create a namespace and then you can run an application inside of it. The fact that I'm running Docker just is something easy for you to see because everyone here knows Docker. But yeah, I've just pulled, so containerd is running a version of Redis, and then I'm running on top of that another container that's running Docker, and inside that container, it's running Redis in a container. The reason you can do this is because it is all just processes in namespace. So there you can see the containerd shim, you can see the stuff that's running, and you can see the process of the Redis server. And you can see that it's running as not root, which is good, because we don't want it to. Okay, cool. So that kind of was like a weird demo, but it's shows kind of inception of what you can actually do inside a namespace with containerd. So that instead of running Docker, that could be your business application. But we'll go a little bit further now, and we'll look at LinuxKit. And I really wanted to go a bit further on this with LinuxKit. Well, that looks horrible, and then it's okay. I'll talk through this a little bit. Why would you actually use LinuxKit? I'll go back to this slide because it that one looks horrible. I don't know what the full format is doing. So LinuxKit is actually a distribution or a thought that allows you to build your own OS and ship it. It allows you to create immutable infrastructure, and it allows you to use things like containerD to build things. Every single thing is a service. Every single service is a container, even the kernel. So it's fully pluggable OS. What that means from a security point of view, if you're shipping software to other people, is you now have an attack vector of something that's very small. The attack vector would probably be down to the application that you're exposing. That is all. Because you're not running any other services in the OS that you don't need to. At the moment, it's a lean, minimal size OS. It boots instantly. It's running the 4.9 kernel stable. 4.10 is in experimental. It allows you to run any container runtime. So LinuxKit allows you to create an OS that is running anything that you want. It's full plug and play. And we'll go through how to build it in a second. Batteries are included, but can be replaced. So what it means is that the people on the LinuxKit project have a whole heap of containers pre-built for you there for an init system, for containerD, for the kernel. You don't have to use them. You can build your own, or you can take the ones that are already being built. As I said, the formatting is bad, but all system services are containers. And why is this traditional to a traditional OS? And why would you choose LinuxKit? So if you're shipping software to a consumer, one thing that we found we were doing, we're going to ship a cloud image. We're going to use Packer, and we're going to ship it on like Red Hat or Debian. It doesn't really make a difference. And it's going to run like PE. It seems like a fairly simple process, but it takes like 2 hours because you've got to use Packer, you've got to harden the OS, you've got to patch it, you've got to do all these operational tasks for something that you only really wanted like this much of the OS, but you have to take the rest of it. And you just don't want to ship it with vulnerabilities to your customers because that's horrible. And it's not good. It's not a good look. So we spent more time actually securing the OS on stuff that we didn't need than what we did need to ship. So one of the so what we wanted to do as part of the R&D was decrease the attack vector, make it immutable, because like if, for example, if you wanted to ship the Puppet server, do you want to make that version immutable and only allow it to run? Lock it down with something like setcomp, make sure that the process is the only one that's working and make sure it's fully immutable, and then create a data drive where the customer's Puppet data sits. Like that could be a perfectly good solution. So immutability was like something that we were looking at. Is truly immutable infrastructure actually something you can do? And LinuxKit, yes. Sandbox system services are awesome because like even if there is a vulnerability in one of the services, it's sandbox. You've got all the setcomp preventing different containers from talking to different containers. You've got kernel level protection. So all the way down to the really lowest level of the Linux kernel, you can protect other services from each other or themselves. That's something that's very hard to do in a traditional OS. Specialized patches and configurations. So if there's something special that you want, build it, put it in there, and it will allow you to have it in there. You have full control over the build. Have you ever thought about deploying your own OS through a CD process that you're going to ship your software on? And being able to ship it to like Azure and AWS at the same time with no different code. This is you can do it with LinuxKit. And all the configuration is in YAML, which makes it super simple. So how is containerd integrated? So this is the init system for LinuxKit. As you can see there, there's an init system. And you'll notice that they're trusted by Docker's upstream public notary service. So you know that there's no chance of man-in-the-middle attacks or anything on this particular containers that you're getting. But as you can see there, there's an init system, containerD, runC, and CA certificates that's there on boot. What this allows it to boot almost instantly, and that is the OS. That is all you need. which is like amazing. So then you might want to add like your container to at runtime to start, and then it's an immutable entity that's an OS that's only running your application, which is super powerful. Every containerD demo we've done so far today has been running on LinuxKit. So everything that I've built right now is just immutably running on top of LinuxKit. I just want to show you a demo of, hopefully this won't take too long, how quick it is to build. Okay, cool. So you just use the Moby build tool. I have a YAML file. While it's building, we'll have a look at it. So as you can see there, I've got the Linux kernel 4.9.54, which is fairly up to date. I know we're up to 12 now, but for the moment, 4.9 is stable. While we're watching that build, so this is basically the whole image of what I'm using to run containerd. So that's it. So I've got DHCP, a few other things running, but that's it. That's the whole OS. And why I just looked at that YAML file, we built the whole OS. That's it. And I'll show you how quick it is to build. Boot, sorry. So now I just go LinuxKit run Docker. That's it. So in that short space of time, and what was maybe a couple of minutes, I just built my own OS and got it up and running. That's pretty amazing, I think. And it really shows the power of like minimal, like sometimes simple is better. Jerome actually said something really, really smart in the workshop we did together, Swarm. He goes, Raft is not better than the consensus algorithm in Zookeeper. It's just simple. There's just less. He goes, and less means less bugs. Simpler to understand means it's easier to get working. And I think that's what like LinuxKit is. It's just simple to get working. And as you can see here, I can go back and I've got my CTR commands, so they're all there. I won't have any containers at the moment because we reboot it. So I've just got the standard ones, but I have got Docker, so we can go installed because I put it in the boot system control boot. So we can just like we could just do, what is GPS? Whoop. So there it is. So automatically when it booted the version of Docker that's running inside the container. So straight away, we built an OS. We had containerd on top of it. We've auto-booted Docker as soon as it booted up, and it booted up in just a couple of minutes. So that could be your custom-built application that's on a fully immutable version of infrastructure that LinuxKit allows you to build for any cloud. Or I believe OpenStack support it. I'm running it on HyperKit, so I'm running it on the Edge version of HyperKit for Mac, but you can use like any of the Linux virtualization platforms as well. But that just shows like how quickly and easy it is, and you could take just an OCI spec of your running application that you've already built and put it into LinuxKit, and then have a fully immutable version of that. So even if you're running something like Nginx and there's some sort of vulnerability for it and someone breaks into the Nginx container, they're not going to be able to break out and to do anything else. And you can just reship as part of your CD process a full new version of not only the OS, but of your application itself. So there's no operational overhead of patching. There's no operational overhead of any of those sort of mundane SRE tasks that used to be there. And going back to the original part of the talk, this is actually all built on top of containerd. So we've got multiple layers of what's happening here, but LinuxKit actually really shows the power of containerd, because basically this OS is just running a kernel, a few init systems, DHCP to get some networking, and containerd. And as we saw before, we were able to pull Redis and run 2 versions of Redis, one on top of containerd natively, and one on top of our Docker engine running inside a container, running on top of containerd. So it's kind of inception, but yeah. But just think of these as proof of concepts, but take these proof of concepts and put it into your lifecycle or your application, and think about how you could put a version of an API perhaps inside LinuxKit and ship it straight as an AWS AMI that's totally deployable straight from Go. It's still using containers. It's just taking out the operational overhead of deployment at the end. It's just a different way to look at the world. Instead of running running an OS, then running containers, and then running it on top of it, bake it into the build process and then ship. It's still using the same tools, just a different workflow. And if you're in a highly secure or a highly regulatory environment, it's definitely something that's worth looking at. I mean, you can fully pen test this end to end and do all your security, whatever you need before you've shipped it. If you have a look at how we used to do that in the old school way, we'd have to deploy the application in some sort of pen test environment that replicated the prod environment and then start pen testing there. You can actually do the pen testing or all the security compliance stuff that you need to do as part of the CD process in the build phase. So as soon as it's built, you can do all your security checks, which is a completely different mindset of the way you used to do things before. It's just magic. All the guys at Puppet know that I use this MAME way too much on HipChat. And Kubernetes. So this is actually, it was really good that yesterday's announcement happened because it made my talk so much more relevant. Of course, that was the best thing that happened out of that whole thing. My talk become more relevant. No, only kidding. Running Kubernetes on top of Docker is pretty awesome. I actually have spent the last probably 4 months at Puppet just working on 100% Kubernetes stuff, and I was totally a Swarm guy. I used to go and do talks and say the complexity and stuff, and I still think Kubernetes is complex, and I still think Swarm's a better use case for some people, but I actually appreciate Kubernetes a lot more. I understand the complexity a lot better now, and I understand what they're trying to achieve. So I have a lot of respect for it now, so it was really good that yesterday's news, I thought it was really good. But how does containerD work with Kubernetes? And there's probably another talk that could be done on the translation API that Docker's built and all the hard work they've done to make Compose work on top of Kubernetes. I mean, when I was showing the tech preview of that, I was absolutely blown away. There's some really, really good engineering being done there. And I think perhaps after this, Gordon might have something to say about it. So if you go to Black Belt after this, I think Gordon might talk about it a little bit more. I seen him running around the hall. He was talking about Kubernetes. But this is how containerd interacts. So you've got the cry shim. You've got Kubelet, which is the service which obviously looks after Kubernetes. You've got the cry protobuf. You've got the cry shim, and the container runtime is containerD. So that's how the Kubernetes ecosystem bootstraps into containerD. And why containerd is so important, if you have a look, it's going to be the core foundation of everything in containers, most likely. And if you were building a house, what do you want? A good core foundation, because as soon as something gets rocky, it's the bit that you rely on the most. And that's why containerd is probably the most important part of the container ecosystem that I think doesn't get enough love. And the guys that work on it should get a bigger shout out because they're doing some really, really good work. If you want to follow the Kubernetes work, this is the project. This is Kubernetes incubator. This is cry containerd. If you've got any interest on how Kubernetes is going to run on top of Docker, there's also SIG node user groups or meetings and things for the Kubernetes project, or you can just follow this on GitHub if you just have an interest of what's happening. And as I've spoken about yesterday, this was some really big news, and I think I'm really happy. If you were following the open source stuff, like if you were following containerD and you were following all the bits that made up Moby, it probably wasn't much of a surprise to you because you would have seen a lot of Docker people in the Kubernetes ecosystem and vice versa working together on a lot of the lower level primitives to get the announcement yesterday out. But it is really exciting for everyone now in the container ecosystem because we can become one ecosystem, which there's a lot of smart people that are going to get combined from the Kubernetes ecosystem and the Docker ecosystem. So it's a super exciting time to be part of containers in general. And I'm just on time for questions.
Thank you so much. Thank you so much, Scott. If you have any questions, please go step forward to the mics over there, or if you're in front, raise your hand so I can bring you the mic.
Hello, thanks for the talk. I was just wondering if you could give us some examples of containerD competitors. So I know that containerD is picked up by Docker and Kubernetes, so that make it like 99% use cases, but what about the others?
So I believe Rocket's got their own runtime, and that's been donated to CNCF. And I think there might be Cryo that is the container runtime that Kubernetes is also working on, so there's also an alternate there. But they'd be the two other ones besides containerD that I know of off the top of my head. But they definitely don't have as much community support as containerD does at the moment.
More questions? Well, Scott, I'm sure you will be around here for another 15 minutes or so if somebody has a late questions.
Thank you. You alluded on sort of a Venn diagram of use cases for the orchestrators. Could you elaborate just a bit more?
Sorry, for containerD and the orchestrators?
No, the Kubernetes versus Swarm.
Oh, the use cases. Okay. So, Kubernetes is hard to deploy and it's also hard to maintain. One of the things that I found working in Kubernetes, especially building a tool for Puppet that deploys it that we released last week at PuppetConf, is some things like logging is not easy. It's not straightforward to find out what's gone wrong, especially about things like SSL mismatch. It'll just say it can't list the nodes, which is not straightforward to know that you've got an SSL mismatch between kubelet and the kube API, perhaps. So I'm said to people, if you're going to this point and you're only running 10 nodes and you've only got 8 containers, do you want to take on this complexity for that workload? Wouldn't it be better than to start with something like Swarm, that's like one command, it runs, it looks, all the raft and everything's looked after out of the box, and you can actually work out on how to schedule your applications, how to work, how the clustering works when you're starting out small. That's the like when I go out and speak to customers, that's the sort of use case. They've heard they need Kubernetes, but they're really starting small. And at that point, it's not that they can't start with Kubernetes small. They probably are too early on their container journey to be even looking at that complexity. They probably need to work out how to get their application working in HA, how to work out like ingress routing, all this stuff they haven't got figured out on their own application yet. They're more worried about the container orchestrator because that's kind of cool to be talking about at the moment. And then I would be saying the conversation to them is, let's look at your application. Let's get this running on something like Swarm. It just works. You might not have all the functionality, but it's just rock solid. And let's look at your application runs on that platform and how you do like layer 7 routing, all these sort of security controls around containers. Do you want to do anything like seccomp and things like that? All those bits they've forgotten about. They're just looking at the app orchestrator. So I just go back to them and talk about like the stuff that they should be worried about, which they've got more of a control over, and then say, as you grow with the orchestrator, and if you want to grow and go to Kubernetes, then do it, but learn about your apps first. Yeah, that's more of the conversation I have. It's not really, it's more of that they're early on and they don't understand, like, for example, container security, and they're going to put something out there on the internet. It would be much better to orchestrate that on an easier orchestrator and start learning about the security process that you need to do than worrying about like running a more complex orchestrator and then being unsecure. So there's the sort of conversations that I have where I think like that might be a better use case. And as I said, as they grow, they might want to go to Kubernetes. There's nothing stopping them, but there's other things that they should be worried about before just using something because it's like a buzz or it's cool. Because there is running Kubernetes, there is an overhead. I mean, once the Docker EE version's out, it might be completely different. Because Docker's come forward and said it's supported, they're going to look after all the security controls and stuff like that. Because one thing in the Kubernetes deployments, most people haven't thought about the security first way of deploying it. It is getting better, but like it's not as good as the inbuilt security for Swarm. So, yeah, that would be.
Okay, that's it, folks. Time is over, sorry. But Scott will be around, I'm sure. Thank you. Give another hand to Scott.
Thank you.